We can also operate with numbers in scientific notation without having to like write them out in standard form. We can keep them in that scientific notation and still operate with them. So when you're multiplying numbers, so like number 11 and 12, when you're multiplying numbers in scientific notation, you multiply the regular numbers, like the decimals, and then you add the exponents. So for number 11, we would do 2.3 times 1.6. So we multiply those together. Get 3.68. So that's the decimal part. And then it's still going to be in scientific notation. So we still need that 10 times, or that times 10 to some power. So then you add the exponents. So 5 plus -3. Theoretically, you could put them into standard form, get that really big number or really small number, whatever it might be, and then put it back into scientific notation. But this is the easiest and quickest way. So you multiply the numbers and you add the powers. So for number 12, we would do 5 times 3.5, or 3.5, 5 times 3.5. So we get 17.5 times 10, 8 plus 6, 14. But remember, scientific notation means that your decimal value is in between 1 and 10. 1 or greater, less than 10. So 17.5 is not good. 17.5 is not less than 10. So what needs to happen is we actually have to move that decimal place over one value or one place in order to keep this in the correct form. So when you move the decimal, that's a place value. So that means your exponent also needs to be altered because the exponent represents your place values. So if you moved it one place, you have to add one place to your exponent. I think of it as if it started larger than 1. 17 is larger than 1. You have to make your exponent larger. So this should become 1.75 times 10 to the 15th. But that decimal has to be between 1 and 10. Otherwise, it's not technically in scientific notation. So then it's just the opposite for division. For division, you divide the decimals or the regular numbers and you subtract the exponents. So for 13, 25 divided by 5 is 5. Still times 10 to some power because we're keeping it in scientific notation, but we subtract them now. So 14 minus 6. So 5 times 10 to the 8. You don't have to write them both out in standard form and then put it back into scientific notation. You can keep them as is. So for number 14 then, we've got 1.4 times 10 to the -3rd divided by 7 times 10 to the 7th. So same thing. You are dividing these guys. So 1.4 divided by 7 gives us 0.2. Times 10, we're going to subtract these. So -3 minus 7 gives us -10. Okay, so when we're doing this, your number has to be between 1 and 10 for it, the decimal, for it to be in scientific notation. So 0.2 is not between 1 and 10. You need a single digit in front of that decimal value. So what needs to happen is we actually want this to be 2 point 0. So just like up here, when you move it, you have to adjust that exponent. You have to do the same down here, but we moved it the other way. So this number started as something smaller than 1. You want to make the exponent smaller. So we're going to subtract 1 from this current exponent. So this will now become 2.0, or just 2. You could write just 2, times 10 to the negative 11. So if you didn't, I might make a note of what to do when you're multiplying or dividing numbers in scientific notation. But when you're multiplying, you do the multiplication with the numbers. You add the exponents. When you're dividing, you divide the regular numbers, subtract the exponents. You just have to make sure you're paying attention when you get your final answer if the number is in between 1 or 10, because you may have to move the decimal and then address the exponent you originally had.